In our study of quantum mechanics so far, we've used the Schrödinger equation to describe some model systems: particle in a box, rigid rotator, particle on a sphere. And then we went ahead and applied it to the hydrogen atom. And although the wave functions were fairly complex, we nonetheless were able to solve them exactly, write down the analytic expression for the wave function and also for the energies. But then when we tried to go to the helium atom, that had 2 electrons, we ran into some difficulties, and we concluded that we could not solve the Schrödinger equation for any chemical system that has more than 1 electron. So we had 2 approximate methods to solve the Schrödinger equation. One is perturbation theory, and the second is this variation method. All right, so what's the variation method? The whole thing about the variation method is that you have the true or the exact wave function, but you don't know that because you can't solve the Schrödinger equation. So what you do is approximate the wave function, the exact wave function, with an approximate wave function. This approximate wave function contains adjustable parameters. You adjust those parameters until the energy you calculate with this Schrödinger equation is minimized. And that collection of adjustable parameters is the best collection you can get according to the variation method. So that will give you the best wave function, trial wave function, and therefore that will give you the best energy given your trial wave function and that particular collection of parameters. So that's what you do. You take the exact Schrödinger equation, everything's the same except instead of this wave function you don't know, you use a trial wave function that has adjustable parameters. You can take this trial wave function, denoted by phi, to be various combinations of simple wave functions. So if for each one of these simple wave functions, which is not a solution to the overall Schrödinger equation, but each one can be put into the Schrödinger equation and solved exactly, and then you just combine those to get the overall wave function. And it turns out, as we'll see later on in this series of lectures, that that approximation is really good, and you can get energies very close to those you measure experimentally. All right, so there's the, in a nutshell, what the variation method is, and now we'll go ahead and explore that in a little more detail.